Good morning, students. I am Katyani, lecturer in Electronics and Communications, Department of Collegiate and Technical Education. Today I'll start with the 14th session of Unit 2, Instruction Set and Assembly Programming of 8051. The course is Microcontroller and its Applications of 3rd semester diploma. The course code is 15MC34T and the program is Mechatronics. So we'll have a quick recap on the previous session. So data transfer instructions, arithmetic instructions, logical instructions, branch instructions and bit manipulation instructions are very important in programming. In this session, we will be discussing the programs of 8051, especially the arithmetic instructions, programs on arithmetic instructions and programming on logical instructions will be performed in this session. So this is the first program. The first program is to add three 8-bit numbers and to store the 16-bit result in internal RAM. So what is given? We have to add three 8-bit numbers and to store the 16-bit result in internal RAM. So first we have to make initial setup. So here they have not given where the 3-bit numbers will be and where you have to store the 16-bit result. So it is up to the user. So here I am planning to take the three 8-bit numbers at memory locations 30H, 31H and 32H. And then I am planning to store the 16-bit results at 40H and 41H. Lower byte at 40H and upper byte at 41H. That is carry contents at the 41H. So this is the initial requirement. So I'll be starting here with the program now. So first I'll start with ORG00H. I'm initiating the assembling process at memory location 000H. And next I have to take the initial requirements. What is my initial requirements? I'm planning to give the inputs at 30H, 31H and 32H. So I'm planning to use indirect addressing mode. Hence I'm loading only move R0, immediate 30H. That is the starting address of this pointer. Next, I am taking move R1, immediate 03H. This is the count. How many times I have to perform the addition. So I am adding the three numbers. Hence, I am taking the count as 3. Next requirement is where I am storing the results. So I am clearing the locations where I have to store the results. So this is move 40H, immediate 00H. What type of addressing mode is this? This is direct addressing mode. Hence, the immediate data will be moved to the memory location, that is 40H. So 40H contents will be cleared and similarly move 41H, immediate 00. This is also direct addressing mode and this immediate data will be put into this memory location 41H. So I have cleared the memory locations where I have to store the data and I have taken the starting address where my data is present in order to use it as indirect addressing mode and I have taken the count. This is my initial setup. Next, what is the next set? So next set is for any arithmetic operations, the data should be in accumulator. So what is my next step? Next step is I have to take the data into accumulator. Where is the data? The data is in memory memory location for 30H. I am providing the data at memory location 30H. So this data, but my R0 is having 30H. So I am using indirect addressing mode, that is move A, at R0. R0 is having 30H. 30H contents is my data. So accumulator will be loaded with my contents. So move A, at R0. A will be loaded with contents of my 30H. So next, what is the next instruction? So we have to perform addition operation. So addition operation between what? So previously I have cleared where the result has to be stored. So hence I'll perform addition operation between add A, 40H. Accumulator had the first data. Now after giving the first data, now I am adding the first data with the contents of 40H. 40H, what do you have? 00H. So what happens after addition operation? The same data remains in the accumulator. What was present at 30H, that is FFH, and that result will be stored in the accumulator. Now my result is at accumulator. Now that result has to be stored to the memory location 40H because 40H I am using it to store the lower byte of my result. So I have moved the contents of my result accumulator into 40H. Now I have to check with carry. Do we have any carry here? If there is a carry, then I have to increment the upper byte. If there is a carry, then I have to increment the upper byte. Otherwise, no need to increment. So if there is no carry, then we can skip incrementation of 41H. Means it goes to the label next. If a carry occurs, then it has to increment the 41. So what is in the next? This is first type addition. So what happens next? Next is we have to increment. The next data is at next memory location, that is 31H. So what we have to do? We have to increment or not. So incrementing or not, that is or not is the pointer. Incrementing or not gives you 31H. So 31H is the pointer where we have the data, next data. So now our data is pointing to the next memory location. And next, we have already performed once addition. So what we have to decrement? Yes, we have to decrement the count value. Since we are using DJNZ instruction, decrement and jump not 0. So here decrement and jump not 0 decrements the contents of R1, that is 3 becomes 2, and it compares with 0. If it is 0, it comes out of the loop. It indicates that we have completed the count. So otherwise what it does, it goes back to the loop. So what is the loop? Again, we have to perform the addition. We will take the next data, and after taking the next data, we will add the previous data with the present data, and then we will store the data and again check for carry. If there is carry, then we have to increment 41H. If there is no carry, then we have to skip this, and next we will point to the next memory location. In the next memory location, we will have the data. Again, we have to decrement the count because we have performed the next addition, and then this loop again goes back. So again, the result will be added with the new data will be taken into the accumulator. Again, the result will be added with the previous data, and now the data will be stored and again checked for carry. If there is a carry, then it increments 41H memory location. Otherwise, it will skip this incrementation and go on to increment or not. Now it will point to next memory location. But we have not giving any data over there. Next is DJNZ R1 comma back. Now it will decrement to 0 and it compares. Yes. So it has decremented to 0 and hence the loop does not go to the next execution. It ends the loop. So now let us check with an example. So what is our first instruction? We will start with origin. And next we have the initial setup. What is the initial setup? So move R0 is my memory pointer. I am taking it with value 30H because I am giving my input at 30H. What is the next thing? Next I have to initialize the count. So count I am taking at move R1 comma immediate 03H because I am performing addition 3 times. What's the next thing? Next thing is move 40. I have to clear the destination. So where is my destination where I have to store the lower byte? It is 40H. I am clearing it with immediate data. Again similarly I will clear the memory location 41H with immediate data. So this is my initial setup. What is the next thing? Next thing is I have to get the data. Move A comma at or not. Where is the data? Data is at memory location pointed by the register or not. So what is the memory location pointed by register or not? That contents will be moved to accumulator. I have got the data. Now I will perform add operation with accumulator and the memory location where I am storing the data. Since initially it is cleared, the result will be the same and that result will be stored in accumulator. So now I have to store that result in some other location where I have to store the lower byte. Where I have to store the lower byte? Move 40h comma A. What is my next thing? Now I have to monitor whether carry has occurred. If there is carry has occurred, then I have to increment the upper byte. Otherwise, no need to increment the upper byte. So jump no carry. If there is no carry, we can skip the incrementation of next byte. So the in next instruction we have increment 41h. So if there is no carry, this instruction can be skipped. So if there is a carry, then this instruction will be executed. So if there is no carry, it will go to a location known as skip. At skip, what we will do? We no need to perform any increment operation. So still now, if there is no carry, then no need to perform any incrementation of higher byte. If there is a carry, then we have to perform the incrementation of higher byte. Still now, one byte addition has been done. So next we have to go to the second byte. Where is the second byte? The second byte is at memory location pointed by my register or not. So I am going to increment the or not. So because I want to go to memory location 31h. So increment or not means it goes to 31h. 31h as my next data, my next data. So after incrementing or not, then I have to decrement my count value because the count I have performed once addition, so my count has to be decremented. So which is instruction that I am going to use? Decrement and repeat the loop. So I will use djnz r1 comma back. So I have to go back. So where should I go back? Yes. So I have to go back to next because again for any arithmetic operation data has to be in accumulator. So move a comma at or not. So you have just incremented the memory location to 31h. That 31h contents has to be moved to accumulator. So I have to jump back here. So the back loop will be given here. And next is yeah. Now let us say this and check once. So I will add that to my source group. I'll remove the previous one. So now I have this. So let me compile, build and rebuild. So now if you go to the debugger session and where am I giving input? I am giving input at memory location 30h and I am monitoring my output at memory location 40h. So I have to give inputs at 30h. So you can give any three 8-bit numbers. So first bit is 23, second one is 34 and the third one is 45. So let us perform addition of these three 8-bit numbers and store the result at memory locations 40h and 41h. 40h I am having lower byte, 41h I am having higher byte. So now let us start running this program. The first thing is, so first instruction was move or not comma immediate 30h. So or not will be loaded with 30h. Immediate data will be copied into or not. What is my next? This is the pointer. What is my next thing? Move R1 comma immediate 03h. This is my count. I am loading the count at register R1. Next is move 40h comma immediate 00h. So that is I am clearing the destination memory. So here the memory it is already 0. Otherwise also it will be cleared. If you give any other data it will be cleared. So my next instruction is I am clearing the 41h memory contents. So what is my next instruction is I have to get the data to the accumulator. So now I have got my first data to the accumulator. See here, this is the memory location 30H. It is having the data 23H. So I am using indirect addressing. Hence, this 23H is stored in accumulator. I have taken the first data. What is the next thing I am performing? Performing add operation between accumulator contents and 40H. What is accumulator contents? 23H. What is in 40H? In 40H, we have 0, 0. What happens if we perform addition between 23 and 40, 0, 0? The same, 23. So let us check what happens. So it is 23. So next, I have to store the result at memory location 40H. So let us see what happens. See, now the contents in accumulator 23H is moved to my memory location 40H, where I am planning to store my lower byte. So this is one set addition has been performed. Do we have a carry here? 23 and 0, there is no carry. So hence, what it will perform, does it increment memory location 41H where you have upper byte? No, it should not increment. Let us see what happens. See, jump no carry to skip. There is no carry generated, hence it goes to the skip. Now one complete addition has been performed. So now I have to take my next byte. The next byte is at memory location 31H. So what I have to do? I have to increment or not. So increment or not means it is pointing to 31H. Pointing to 31H means 31H has some data like 34H. So that data I have to take it into my accumulator. Okay. Let us see the next instruction. Next instruction is decrement R1. So once addition, after performing once addition, what we have to do? We have to decrement the count. So see, now the count has been reduced. Initially it was 3, now the count is reduced to 2. Is that equal to 0? No. So hence it goes to back loop. So this is the back loop. Now the next data will be taken into accumulator. Check with the next data. Yes, the next data is 34H. So 34H is taken into the accumulator. Now addition operation will be performed between these two. What are these two? Previous data it was 23 and the present data is 34. Now perform addition operation between these two. 4 plus 3 is 7 and 3 plus 2 is 5. 57. 57 is the result. So let us see what happens after addition. Yes, after addition we have got 57. Now the 57H has to be moved to my destination, that is result should be stored in my lower byte memory location, that is 40H. Let us see what happens after execution of this instruction. Yes, 57H is loaded into my memory. As carry generated? No, carry is not generated. So hence what happens? It has to skip incrementation of my upper byte. So hence, let us see. Yes, it skips and goes to. Next, I have to take my third data. It is pointing at memory location 32H. So I have to increment or not. So previously or not was 31. Now it is incremented to 32. And my count has to be decremented. So count is previously 2. Now the count has to be decremented to 1. Now is that equal to 0? No. Hence it goes back loop. Again what I have to do? We have to take the third data into accumulator. So take the third data into accumulator. So previously accumulator is 57 and now the third data will be taken, that is 45H. Now it will perform addition of 3, all these 3 numbers. So what will be the answers? 44, 5 and 3. 4 plus 5 is 9, 10, 11, 12. 12 means it is C. And 4, 5, 6, 7, 8, 9. So 9C should be in accumulator. Let us check after addition what will be the result. Yes. So 9C is in accumulator. Now this has to be stored in my lower byte memory location. So the next instruction is move 40H comma A. Yes, now 9C is stored in my destination address. So now what happens? Do we have carry? No, carry is not generated. So hence we should not increment the next memory location 41H. So hence jump no carry to skip. So next what? It increments the next memory location, but next memory location is, we are not going to use it, even though if it increments, not an issue. Next is DJNZ R1 comma back. So next we have to decrement the count. Yes, count has been decremented. Is it equals to 0? Yes. So now we have to stop performing addition operation. So what is my result? So what is my result? My result is lower byte we have 9C and upper byte we have 0. So let us come out of the debugger session and we'll get. Now the next program is program to count the number of ones and zeros in two consecutive memory locations. So here what is given? We have to count the number of ones and number of zeros in two consecutive memory locations. So here they have not given which memory locations. So we can assume wherever we want. It is up to the user. So here the I am planning to give my data at 30H and 31H, two consecutive memory locations. I have to count the number of zeros and ones in the contents of these two consecutive memory locations. This is my initial setup. So each byte, so here memory location 30H has 1 byte and memory location 31 has 1 byte. So there are 2 bytes. So here each byte has how many bits? 8 bits. So I have to count two consecutive memory locations and each location has how many bits? 8 bits. So these are my initial setup. I'll start with origin and here I'm using the pointer, hence move or not comma, what is my source address? 30H, where I'm having my data 30H, and where is the destination? I'm planning to store it at 40H and 41H. So 40H I am clearing and also the 41H I am clearing, where I can store zeros and or ones. So one of my memory to store zeros and the other memory is to store my ones. So how many data I am checking? Two data, that is 2 bytes of data, one at 30H, another one at 31H. So hence 2 bytes. So how many bits are there in each byte? So there are 8 bits. So I am taking that into register R2. So register R2 is loaded with immediate data, that is 0, 8. First I clear the carry, previous contents of my carry, and I am taking the data into accumulator. So move A comma at or not. The contents of memory location 30H, that is FFH, will be loaded into accumulator. Now, how will you count zeros and ones? What is the logic behind that? For previous program addition means we used to use add. How do you count number of zeros and ones? So you have to monitor each and every bit. So in order to monitor each and every bit, we can perform rotate along with carry. So you can use rotate left or rotate right. So here I am planning to use rotate right through carry contents of accumulator. What happens if you use rotate right through carry contents of accumulator? The contents of accumulator will be moved along with carry, so that one of the bit will be stored in the carry. So then you will check whether that contents of carry flag is 0 or 1. If it is 0, what happens? Then you have to increment the zeros memory location. If it is ones, then you have to increment the ones memory location. So jump carry to ones. So here what happens? Jump carry to ones. So ones is stored at 40H memory location. So ones will be increment. If there is no carry, then we are incrementing 41H. You can use either ways. And then we have to decrement. So how many times this has to be performed? 8 bits. So hence this loop has to be repeated how many times? 8 times. Each time we have to rotate and we have to check with the carry. If there is a carry, then we have to increment the zeros position, ones position. If there is no carry, we have to increment the zeros contents memory location, and this process repeat until all 8 bits of first memory location is done. Next, what you will do? You will go with the next byte. So where is the next byte? At the next memory location 31H. So at the next memory location, now to go to the next memory location, what we have to do? Increment 40. So increment or not. So increment or not means it will point to the next memory location. Instead of 30H, it goes to 31H. Now what I have to do? So one memory location has been used. So hence I have to decrement R1. So decrement already what we had given 2. So now decrement R1 means it becomes 1 and goes to back. Where it has to go, it is equals to 0. No, then it goes to back. Again, it performs the same thing, that is it will take 8 bits value. So again each and every bit will be monitored, and if it is ones, then one's memory location will be incremented. If it is 0, zero's memory location will be incremented. This process is repeated for all 8 bits, and again it comes back to djnz r1 comma back. So now r1 will be cleared to 0 so that it will end the loop. Let us check this with an example. So what is my initial requirement? I'll start with origin. Next, what is my initial requirement? Yes, move or not comma 30H. Immediate 30H, not it is direct addressing, it is immediate data 30H. So that or not will be loaded with 30H. So what is my next requirement? So next requirement is move R1 comma immediate. How many bytes of memory location I have to check? 2 bytes. So hence I'm taking 2. And then I have to clear my destination register where I have to store. So destination is not a register, it is a memory location I'm using. So 40H comma immediate 00H. I'm clearing the destination. Again move 41H comma immediate 00H. Where in one of the memory location I am counting ones, and another memory location I am counting zeros. So I have cleared. So what is my next thing? Next is I have to take the number of bits in each byte. How many bits are there in each byte? So move R2. The another counter I am taking, move R2 comma immediate 08H. So this is the count value. So this is my initial setup. So till here we have the initial setup. So next we'll go to the actual thing. So what is the actual thing? So next what do you have to do? We have to take the data, or first I will clear the clear carry, and now I will take the data. So move a comma at R1. Where is my data? Indirect addressing at R1. Now what I have to perform? I have to perform either rotate right or rotate left. So I will perform rotate right through carry accumulator. So now my accumulator contents are rotated. So now I have to check whether it is zeros or carry flag is set or reset. So jump carry. So carry means you have to increment which memory location where you are storing the ones memory location. Jump no carry means you have to increment the zeros location. So jump carry to, you will go to ones. That is the label. It will go to that label. So if there is no carry, then it is nothing but it is 0. Correct? So hence 0, which is the address, you can give any of the address. So I am planning to store the count of zeros at 41 memory location. So I will increment 41H. So I am performing a simple jump. After this instruction, it should not increment both of them. So that is why I am taking S jump to some location like down. Since it is not, it should not jump, it should not increment both the memory location. So now I will take ones loop, once. So now jump carry to ones. At once what it should increment? It should increment 40H contents. So this is checking of only one bit. So now what I have to do after checking of this? So now you have the down loop. What do you have to do here? So here we have to, yes, decrement the count. So that is decrement count of what? We have performed only one bit rotation. So we have to perform next bit rotation. So that is decrement R2, or you can also perform the DJNZ. You can also use instruction like DJNZ. What is that? R2, comma, back. Where should I place the back loop? So back loop should be placed, yes, it should be placed here. Why? Yes, the next thing is to again rotate and again perform the check whether it is a carry or a no carry. If there is a carry, increment the particular thing, memory location. If there is no carry, then increment another location. So what might be the next instruction? So this one data is checked for its contents. I have to take the next data. So where is my next data? It is at memory location or not. That is contents of or not, pointer of or not. So hence I will go increment or not. So where is my next data? At increment or not. So now again I have to check DJNZ. Now which counter has to be reduced? Yes, the second counter. Since one byte is completed, DJNZ R1 comma, I'll take it as up loop. So where should I place the up loop? Yes, it should come here. So it will come here, up loop. So because again it has to perform this many rotations, 8 bits of rotations. Hence it goes to up loop. Then results will be stored. So you can have it. So now let us save this, compile, build, and then read. Now let us go to the debugger session. So what is the data? Input where I should give? Two consecutive memory location. One is 30H. I will take it as 0F. And in other thing also I will take it as 0F. F means 1, 0 means 0000. F means 1111. So how many ones in first byte? 4 zeros and 4 ones. In the second byte also we have 4 zeros and 4 ones. So totally how many bytes? So 4 plus 4 zeros, it is 8 zeros, and 4 plus 4 ones, that is 8 ones. So after running of this program, I should get 8 zeros and 8 ones. So let us check. So if we go step by step, so let me take the first step is the memory location where I have my first data. Where is the memory location I have my data? 0FH. So that is loaded into R naught. Next is the count value. How many bytes I should read? That is 2. So hence it is loaded into R1. Next I am clearing my destination. That is the place where I have to store my zeros and count of ones is cleared. So next is I am taking the count into register R2. So now register should have 8. So why 8? Because we have to rotate 8 times, because each byte has how many bits? 8 bits. So we have to perform 8 rotations in order to check each bit whether carry flag is set or not. That bit, particular bit is 0 or 1. If it is 0, increment the zeros memory location. If it is 1, you increment the ones location where you have stored. So now I am clearing the carry. So carry flag will be cleared. Carry flag will be cleared. Next I am taking the first data into accumulator. Before for logical operations I am taking the data into the accumulator. So now you see accumulator first data is taken, that is 0FH. Now what I have to do? I have to rotate this right once so that I can monitor the contents in carry flag. So rotate this right once. So rotate this right once. So whether carry is set or not, yes, that bit is 1. So hence carry flag should be, see, this is 0777. So since we had data, what was the data that we had given? 0FH, right? 0FH means what is the data? That is 0001111. What happens if you rotate right once? Initially we had cleared the carry. So let me take this as carry. It is clear. What happens once you rotate right once? Yes. So here 0, 0, 0, 0. Now it has shifted once. 1, 1, 1. And the carry is now 1. Now the carry flag is set and the value in accumulator will be 7. See, observe here. The value in accumulator is 7 and carry flag will be set. So if carry flag is set, what happens? It should go to jump carry. It should increment the contents of memory location 41H. See, let us increment 40H. So jump carry, it goes to once loop and in once loop it increments. See, now once has been incremented. So now one bit has been tested in my 1 byte of data. So again this process repeats. Again the rotation operation will be performed. So after rotating the data, it will check for carry. If it is carry is set, then see again it increments. Second one, again it goes there, performs the next rotation. Again, next you can observe there. It keeps incrementing. So similar process will be repeated until all first bytes of checked. So similarly, the second byte also will be checked. So after running this, what will be my output? 08H in 40H memory location and 08H in my 41 memory location. Is it clear? So this is, so what all we discussed in this session? So we have discussed almost all the use of all the instructions in this program. So addition, increment, rotate right through carry, DJNZ instruction. What does DJNZ instruction will do? Decrement and jump not 0. It will check, decrement the contents first. It will check whether it is 0 or not. If it is not 0, then it repeats the loop or goes to the label specified. Otherwise, it will execute the next instruction. And next we have bit manipulation instruction that we have used, clear and jump carry. And we have also used data transfer instructions like move, and we have also used unconditional jump instructions like sjump. And these are the multiple choice questions of session 14. So let the first question, let A is equals to 34H and B is equals to 2H. What is the value stored in A and B register after execution of mul AB instruction in 8051? Option A is equals to 68H. Option B 00H. Sorry, B is 00H. Option B, A is 68H and B is 02H. Option C, A is 00H and B is 68H. D, A is 34H and B is 68H. What happens? Multiply instruction. So after multiplication, the lower byte will be stored in accumulator and higher byte will be stored in B register. So after multiplication, you will get 34 into 2 is 68, that is lower byte, and higher byte will be 0. So option A is the correct answer. The next MCQ. What is the contents of OR0 after execution of the following lines of code? ORG000H, move A, immediate 65H, add A, immediate 78H, move OR0, A, end. Option A 33H, option B DDH, option C 143H, option D none of the above. What is the contents of OR0 after execution of the following lines of code? First, we have taken the immediate data into accumulator. Then we have added the immediate data 78 to the previous contents of accumulator and we have stored that in register OR0. So what happens after addition? 8 plus 5? 13. 13, since this is an hexadecimal addition, 13 is nothing but D. Again 6 plus 7 is D. So you will get a result that is DDH. So DDH will be stored in R naught. So the contents of R naught will be equals to DDH. That is option B is the correct answer. If accumulator is 68H, what happens to the contents of accumulator after execution of swap A instruction? So option A is 86H, option B 34H, option C 80H, option D 6H. If A is 68, what happens after swap? Yes, it becomes 86H. That is option A is the correct answer. Fourth one. Let A is equals to 36H, B is equals to 03H. What is the contents of A and B register after execution of divide A and B instruction? Option A is equals to 12H and B is equals to 03H. Option B, A is equals to 00H and B is 12H. Option C, A is equals to 12H and B is 00H. Option D, A is equals to 36H and B is 12H. What happens? Division. So after division, A will store the quotient and remainder will be stored in B register. Is it that? Right? Yes. So if you divide 36 by 3, the quotient is 12. And what about the remainder? It is 0. So what is the correct answer? Quotient will be stored in accumulator and the remainder will be stored in B register. So option C is the correct answer. 12 and 0. Option C is the correct answer. Fifth one. What is the contents of or not after execution of following lines of code? ORG000H, move A, immediate 35H, add A, 40, immediate 48H, DAA, move R0, A, end. Option A 33H, option B 7DH, option C 83H, option D none of the above. So what is the correct answer for this? So what happens here? First accumulator is loaded with 35H, immediate data 35H. Then we are performing add operation between previous contents of accumulator with the next immediate data 48H. What happens after addition? 8 plus 5, it is 13. 13 means it is D. Next, 4 plus 3, it is 7. So it will be 7D after add instruction. So next, after using DAA instruction, what happens after using DAA instructions? It adjusts to decimal, the contents of accumulator. So what happens? So after you using DAA instruction, what happens? So since 7D will be produced, since D is greater than 9, lower nibble, so it will add 6. What happens if we add 6? So you will get 83. So that 83 in accumulator contents will be moved to or not. So end. So what happens after execution of this instructions? Yes, or not will be having how much? 83. It will perform normal BCD addition, that is 8 plus 5 is 13, 3, 1 carry, 4 plus 3 plus 1, 8. So 83H. So 83H will be loaded in or not. DA helps in performing the BCD addition. So initially accumulator will have the hexadecimal value, then it will be converted into BCD. So 83H will be present in or not. The next question is, so these are the solutions for the MCQs. Thank you.